Hey, fifth grade, we're going to start out with some of our math lessons doing distance learning now. So I hope that you are safe and healthy at home. And we're going to pick up in Unit 15 with math, doing some geometry today. In your book, that's going to be page 327. We've been talking a lot about shapes. If you remember, back when we could meet together, we talked about how we had different squares and rectangles and polygons. We had rhombus. Well, now we're going to be moving into shapes that aren't just flat, ones that actually have dimension. Because some shapes, like a piece of paper, it has length and width, but it doesn't have height. It doesn't stick out off of that page by much. Now, I'm sure you could measure that little bit, but we're just going to talk about a piece of paper as being basically flat, and it has two dimensions. Now, we'll talk about some other objects that you have in your house that have length, they also have width, they also have height. So it has length, width, height. There's three dimensions now, so this is actually a 3D shape, three-dimensional shape. These are 2D shapes because they only have length and width. When we're talking about a 3D shape, it actually has different ways that we can describe it. Most of the time, we'll describe it based on the flat surface. That surface that's flat we'll call a face. Then we also have edges, not the corners. I'm talking about the lines between them. The edges where the two faces come together. That whole line is called the edge. It goes all the way around every surface. Then we do have another name for the corners themselves. This year, fifth grade, we're going to call these corners vertices. Okay, right here, all of your vertices have where the edges come together. These corners are your vertices, but if there's just one, it'll call it a vertex. Don't get confused. On your page today, it will call it a vertex, and then tomorrow, it'll call it vertices. That just means there's more than one, so make sure that you know it's the same word, but it's just talking about the corners of the shape anytime that we're doing that. This shape is a cube, but it's got a lot of neat properties to it. If I'm looking at it, yes, every single face is the exact same size and shape, but this one's neat because it actually has two sides that are parallel to each other. This side will never intersect with this side. They don't curve in. It's not like a pyramid. This one will keep going straight. This side will keep going straight. What do we call it when we have lines that keep going straight? They never intersect with each other. What are those called? These are parallel lines when they never connect. So we actually have parallel sides, parallel faces in this shape. Because those sides are parallel to each other, they'll never cross, they'll never intersect. This shape is actually a type of prism. Prisms have parallel sides, parallel faces that never cross, never intersect with each other. We'll get into some other shapes that are also prisms in a little bit, but this shape is one. I'm going to put it to the side right here, bring out another one that I have for you. This is a noodle jar, but in here, this shape does not have flat surfaces on the sides. So this one's kind of unique. This side is flat, and this side is flat, but the rest of it's not. This is a curved surface all the way around. So when I'm counting the faces for this one, I'll count the flat sides, but this right here is not a flat face. It is a curved surface, but it's not a flat face. So don't get confused on that one because this part's not going to count when we're counting the faces. We'll just count this side and this side for it. It also does not have edges and it does not have a vertex. So this is a unique shape. What is this one called? It's a cylinder because it's made up I have 2 circles that are put together with a curved surface connecting them. We'll be building some of those in a little bit. I have another unique shape. This one has no surfaces that we can count. It has no vertices, has no edges. This one will actually roll, but that's about it. This is a sphere, and spheres do not have faces, edges, or vertices for us to count. So that is a very unique shape. We actually can't even make a net for that one. And searching over my whole house, I had a really hard time finding a cone today. So we're going to use the top of Mariah's unicorn hat. And right here, this part is going to be our cone. It has one flat surface on the bottom. Then the edges gradually curve in like that. So this one actually does not have any edges to count, and it only has one flat face. This part doesn't count because it's curved. This is the only flat face here on the bottom of that horn. Sometimes you're going to have a shape that you actually have to build. I have something like this. This is a map for a shape. This map is called a net. When I fold the sides down and then roll it up, you can see it makes a shape. What shape is that? That just turned into the cylinder. But unrolled, it's just a map or a net for the cylinder. You're going to have some pictures on the back of your page of some nets. The nets, you're going to have to just guess what shape will this be when I roll it up. One of them will look like this. Another one will look like a cross. That looks like a cross to start out, but if you fold it in, when I fold all the pieces together, now what has it become? It's turned into the cube that we had. What about, ooh, here's a really tricky one. It looks kind of like a lamp. When I roll this one up, it folds in, and I roll up the edges. Now what has it become? Well, a little bit of a cone, if I had it all the way attached together. This one turns into a cone, but rolled out, it does look a lot like a lamp unless you turn it sideways or upside down. Whichever way you turn it, this one will still turn into a cone shape. Three-dimensional shapes are kind of neat in the fact that they do have a net. They do have a map for how to make that shape. Here's another one. Looks a little bit like a star. It starts out with a square base. Then when I fold all the edges together, all the surfaces together, it turns into a pyramid. This one is a pyramid. Now it's got 4 sides, so it's got sides on both sides, but they're curving in. Does this count as a prism if all the sides are curving in? No, it doesn't. To make this into a prism, the sides would have to actually still be straight up and down, exactly parallel to each other. So this one's not a prism. We do have some triangular prisms that have triangles on one side, but they're parallel, they never touch each other. So this one is not a prism. The cube is a prism because those sides do not ever interact with each other, but this one doesn't. I want you to go through and try to identify these different shapes and see what you can do. If you have any questions, just give me a message. You can post a comment. You can do our Google Classroom, whatever you need to do, and I'll help you through the rest of it. But I want you to try to finish through this page and see if you can do the back with the nets, and let me know if you need help. Good luck!